Hello students, today we discuss the topic that is sequences and series. It is related to JEE mains topic. Now let us do the topic sequences and series. So it is one of the very important topic with respect to the JEE mains as well as advanced also. In this session, we discuss what is sequence, what is series, what are the types of the series, how to build up them, how to write the general terms, how to write the sum of n terms of that series, and how to develop a sequence like that. All these things we have to discuss today now, my dears. Let us see first of all what is sequence. Okay. Now, let us see the definition of sequence. A sequence is a function whose domain is set n, that is the number of natural numbers, is called infinite sequence. So, a sequence is nothing but a function. Its domain is nothing but set of natural numbers. The range is whatever it may be, the codomain is whatever it may be. Here, natural numbers. Set is natural numbers. We say that sequence is an infinite sequence, and a function whose domain is a subset of n or in the form 1, 2, 3, 4 and so on up to k, that is called finite sequence. That is called finite sequence. Suppose f is mapping from n to r, we defined as f of n is equals to n cube. It is an infinite sequence, I think so. So n takes from the set of natural numbers. They are beginning from 1, 2, 3, 4 and so on up to infinity. So we write f of 1 is equals to 1 cube, that is 1. F of 2 is equals to 2 cube, that is 8. F of 3 is equals to 3 cube, that is 27 and so on. So 1, 8, 27 and so on. It is a set, then it forms a sequence. So a sequence is a function whose domain is set of natural numbers. Then it is said to be infinite sequence. If it is subset of natural numbers, we say that it is finite sequence. This is the definition of the sequence, my dears. Now, the sum of the terms of the sequence is called series. This is the next definition. What is a sequence? What is series? Series is nothing but sum of the terms of the sequence. All of you know that the definition of the sequence. It is just a function from natural numbers, whose domain is natural numbers to any real number or complex number, whatever it may be. The sum of the terms of a sequence is called series. Suppose your sequence is n, say, that means 1, 2, 3, 4, 5 and so on. Then its series is nothing but 1 plus 2 plus 3 plus 4 plus and so on. Suppose it is a finite series of n terms, that is up to plus n. This is nothing but sigma n. Its value is n into n plus 1 by 2. So what is a series? The series is the sum of the terms of the sequence. Terms means what? The outcomes of the sequence. So 1, 2, 3, 4 and so on are the input values. You get the output values for this 1, 2, 3 and so on up to k by depending upon the nature of the function. So 1 plus 2 plus 3 plus and so on up to n is one example. Consider the another sequence n plus 2. This is my another sequence. Your set domain is a subset of n. Suppose say n dash, it is say 1, 2, 3. This is my domain. So the sequence is what? 1 plus 2, that is 3, 2 plus 2, that is 4, 3 plus 2, that is 5. This is my sequence. Now the corresponding series is what? The corresponding series is 3 plus 4 plus 5, that is 9 plus 3, that is 12. So this is the series, series value is 12. The value of the series is 12, the sequence is 3, 4, 5. So for series we get output finite value or infinite value by depending upon the sum, and sequence is in this manner. It is just like set output set. So it is a function. It is function from natural numbers to some real numbers or whatever it may be. So domain must and should be what? Domain is your set of natural numbers or subset of the natural numbers. Understand? Next. Now, this is the definition. A series in which each term except first term differences from its preceding term by the fixed quantity is called arithmetic progression. So, a series is said to be in the form of arithmetic progression. That means AP if the difference of the preceding term to the difference of the term to its preceding term taken in the same order must and should be same. So, in which each term, that is except first term, differences from its preceding term by a fixed quantity is called arithmetic progression, and the fixed quantity is called the common difference. We are taking the difference in the same order. Same order. For example, consider 1, 3, 5, 7, 8 and so on. Suppose this is the sequence. Corresponding series is 1 plus 3 plus 5 plus 7 plus 8 and so on. So 1, 3, 5, 7 and 9. This is 9. So what is the difference here? 2. The difference is here also 2. The difference is here 2. Here also 2. So the differences is always same, fixed, taken in the same order. Therefore, the series is in the arithmetic progression. Series means like that. This series in the arithmetic progression. Or we say that the sequence is in the arithmetic progression. The terms are in the sequence are in the arithmetic progression. These are called terms of the sequence as well as series. 1, 3, 5, 7 like that. So this is the arithmetic progression. So the differences taken in the same order must and should be same for the consecutive terms. For the consecutive terms. And then if A is the first term and D is the common difference of arithmetic progression, then the series will be like that. A plus B, A plus 2D plus and so on. If you write the corresponding sequence, you may write A plus D, A plus 2D and so on. See here, what is the first term? This is A. What is the difference? D. Here also the difference from here to here is also D. So the differences are same. So you can define the arithmetic sequence as A plus D, A plus 2D and so on. Its corresponding series is A plus D, A plus 2D plus and so on. A plus D plus A plus 2D plus and so on. This is the arithmetic progression. So the sequence is said to be arithmetic progression if you consider the same order and the difference between the two consecutive terms in that series must and should be same. That constant difference is said to be common difference of the series, and A is the first term. This is common difference. Here D is common difference. Okay. And nth term of arithmetic progression is A plus n minus 1 into D. See here, the first term is A. Second term is what? A plus 1 into D. This is first term. Second term. Third term is what? A plus 2D. Fourth term is what? A plus 3D. And so on up to nth term is what? A plus n minus 1 into D. Am I correct or not? Because if first term A plus 0 times of D you may write. Second term 1 will be there. Third term 2 will be there. For nth term n minus 1 will be there. So A plus D, A plus 2D, A plus 3D and so on. Then nth term is always denoted by Tn is equals to A plus n minus 1 times of D. So your Tn is A plus n minus 1 into D, my dears. And then sum of n terms of AP is n by 2 times of 2A plus n minus 1 into D. That is nothing but n by 2 times of a plus b. So a plus n minus 1 into d you have to write, where 1 is the last term. Here it is not 1, actually it is b. B is the last term. A plus b times of n by 2. So we are adding the first n terms. So sum of n terms of arithmetic progression is a plus n minus 1 into d.
Sir,
is equals to a plus d plus a plus 2d plus and so on up to plus a plus n minus 1 into d. Its sum is you are going to find out. Now if x plus y is equivalent to y plus x, so I write the series in the reverse order. This is nothing but a plus n minus 1 into d plus a plus n minus 2 times of d plus a plus n minus 3 times of d plus and so on up to your first term is a. Now this is also s. X plus y is equivalent to y plus x. Now adding these two series, we obtain 2s is equals to a plus a 2a plus n minus 1 into d. This is also a plus a 2a plus n minus 1 into d. So 2a plus n minus 1 into d. Similarly, this is also 2a plus n minus 1 into d. And this term is also 2a plus n minus 1 into d. And so on up to plus, this is also 2a plus n minus 1 into d. So, how many 2a plus n minus 1 into d are there? How many terms are there? d to n minus 1. This is 1, 2, 3 and so on up to n minus 1. n minus 1 terms plus 1. This is n terms. Sum of n terms we are doing. This is also n terms. By clubbing, we have n terms. So that means this quantity appears how many times? N times. Therefore, 2s is what? 2s is equals to n times of 2a plus n minus 1 into d. 2a plus n minus 1 into d. That means s is what? S is equals to n by 2 times of 2a plus n minus 1 into d. This is the sum of n terms of the arithmetic progression with first term a and common difference is b. What is a? First term. What is n? Number of terms in that sequence or series. What is b? Difference of the two consecutive terms of the series taken in the same order. Sn. This is n by 2 times of 2a plus n minus 1 into d. This can be written as n by 2 times of a plus n minus 1 into d. What is a plus a? 2a. That is why I am writing in this manner also. A plus n minus 1 into d. What is a plus n minus 1 into d? Suppose if you take it as b, say, this is first term, this is nth term, then the sum may be written as n by 2 times of a plus b. n by 2 times of a plus b. So, n by 2 times of a plus b, or it is equals to n by 2 times of 2a plus n minus 1 into d is the sum of the first n terms of the series, which is in the arithmetic progression. Okay. Now, next, the same quantity is added or multiplied to each term of arithmetic progression, then the resulting series is also an arithmetic progression. So, some arithmetic progression is there. You add or multiply a constant number, then the resultant is also in the arithmetic progression. For example, consider an arithmetic progression, that is a plus d, a plus 2d. This is the corresponding sequence of the series. These are the terms a plus d, a plus 2d, a plus 3d and so on up to a plus n minus 1 into d. These are the terms of the series of AP. So A plus D, A plus 2D. Suppose if you add a constant to each and every term, this is KA, K plus A, and K plus A plus D, this is K plus A plus 2D, this is K plus A plus 3D, and so on. Now see the difference here. What is the difference? Here also D. The difference here also D. The difference here also D, my dears. Therefore, the differences are same. Therefore, D. Therefore, it is nothing but the arithmetic progression. So, the terms are in arithmetic progression. A plus D, A plus 2D, A plus 3D. By adding K, the resulting sequence or the corresponding series forms an arithmetic progression. Understand? Similarly, by multiplying a constant to the each and every term, K times of A plus D, K times of A plus 2D, and so on. So, what are the differences? K times of D. This is also K times of D. This is also K times, the next difference is also KD. So, all the differences are same. And this difference is K times of the original difference of the sequence. Therefore, the difference is fixed taken in the same order. Therefore, the resultant series is also arithmetic progression. Understand? So, by adding or subtracting or multiplying with a non-zero constant to the series, the resultant series is also in the arithmetic progression for an arithmetic progression. Understand? Next, this is the thing. If A comma X comma B are in arithmetic progression, A comma X comma B are in arithmetic progression, then X is called the arithmetic mean of two numbers A and B. That is the between A and B. So A, X, B are in AP. That means A comma X comma B are in arithmetic progression. We mean these are the terms of the series. Its corresponding sequence, this corresponding series is A plus X plus B. Understand? So what is the difference here? X minus A. The difference here is also B minus X taken in the same order. So if you write equality, 2x is nothing but A plus B. So your X is equals to A plus B by 2. Now this X is called the arithmetic mean of the two numbers A and B. So A, X, B are in arithmetic progression. This X is called arithmetic mean between the two numbers A and B. Next. The arithmetic mean between A and B is A plus B by 2. That is derived. A comma x1, x2 and so on up to xn comma b are in arithmetic progression, then x1, x2, x3 and so on up to xn are called n arithmetic means between A and B. My dears, already we discussed A, X, B are in AP. We say that x is arithmetic mean of the two numbers A and B. In the same manner, suppose there are n numbers between A and B, they are making arithmetic progression. So, A, x1, x2, x3 and so on up to xn comma b are in arithmetic progression. Then we said that x1, x2, x3 and so on up to xn are called the n arithmetic means between A and B. Suppose 1, 3, 5, 7, 9. This is an arithmetic progression. Because the difference, common difference taken in the same order. This is 2, this is also 2, this is also 2, this is also 2. So this is A, say, this is B. Then these three numbers, 3, 5, 7 are called arithmetic means. We can insert any number of arithmetic means between the two given numbers. So x1, x2, x3 and so on up to xn are called n arithmetic means between A and B. Now, see here, x1, x2, x3 and so on up to xn are n arithmetic means between A and B. Then the common difference is b minus a by n plus 1 and then x1 is equal to a plus d, x2 is equal to a plus 2d, and so on up to xn is equal to a plus nd. And sum of n arithmetic means is n times of the one arithmetic mean, that is n times of a plus b by 2. It is very, very important result for you. So what is given here? A is the first number, x1, x2, x3 and so on up to xn, comma b. A, x1, x2, x3 and so on up to xn, comma b are arithmetic progression. Then we say that x1, x2, x3 and so on up to xn are n arithmetic means. So these are n arithmetic means. Then the entire thing is in arithmetic progression. Suppose let d be the common difference. Suppose d is the common difference. Then x1 is what, my dears? x1 is equals to a plus d. x2 is equals to a plus 2d. x3 is equals to a plus 3d. And so on up to nth arithmetic mean, xn is equals to a plus nd. Am I correct or not? Suffix is 1, automatically here will be 1. Suffix is 2, here will be 2. Suffix is n, automatically a plus nd. These are n arithmetic means. x1, x2, x3 and so on up to xn are n arithmetic means. What is that next one? B. B means automatically can you write B or not? Just by adding a to that one, B is equals to a plus n plus 1 into d. So just by adding 1d to that number, you get B. B is nothing but the next term of xn. That is a plus nd plus d again. You have tried. So the difference is d is there. B is equals to a plus n plus 1 into d is obtained. Therefore, from that b minus a is equals to n plus 1 times of d implies the value of d is nothing but b minus a by n plus 1. All of you remember this formula. The common difference d of the arithmetic means, n arithmetic means are inserted between two numbers a and b, then the common difference d is obtained by the formula b minus a by n plus 1. That is the d value. D is equals to b minus a by n plus 1. And we have to show that x1 plus x2 plus x3 plus and so on up to xn value is n times of a plus b by 2. Let us see how it is happened. What is the difference here? D is equals to b minus a by n plus 1 is there. Now add these things, we obtain we are going to add sum of n arithmetic means, that is x1 is equal to x1 plus sigma xi, that is equals to I runs from 1 to n. Xi is equals to a plus d plus a plus 2d plus and so on up to plus a plus nd. You have to write. This is nothing but n times n arithmetic means na. This is nothing but na plus d is common 1 plus 2 plus 3 plus and so on up to n. This is nothing but na plus d into sum of first and natural numbers, n into n plus 1 by 2. So you may take n common, n times of 2a plus n plus 1 into d. What you are going to prove that n times of a plus b by 2. So take 2 common, n by 2 times. Is it nothing but n by 2 times of a plus b or not? What is your b value? B is nothing but a plus n plus 1 into d. A plus n plus 1 into d. B. N plus 1 into d. So it is nothing but a plus n plus 1 into d, that is nothing but b, a plus b. This is n by 2 times of a plus n plus 1 into d is there. Therefore, your s value, sum of the n arithmetic means is nothing but n by 2 times of a plus b by 2. So this is LCM. We are obtaining 2 is also here. N by 2 times of 2an n is common, I taking LCM, n by 2 will be there. 2a plus n plus 1 into d can be written as a plus b. a plus n plus 1 into d, that is nothing but a plus b. So your S is equals to n by 2 times of a plus b. A is first term, b is the last term of AP, n is the number of arithmetic means between the two numbers a and b. n by 2 times of a plus b, that is n times of one arithmetic mean between a and b. One arithmetic mean between a and b. This is the derivation for this. x1 plus x2 plus x3 plus and so on up to xn is equal to n times of a plus b by 2 and d is equals to b minus a by n plus 1. Understand? And next one, if three numbers are in arithmetic progression, then they can be taken as a minus b, a plus d generally. So what is the difference here? The difference is d here. Here also the difference is d. Suppose three numbers are in arithmetic progression, their sum is 3 automatically we obtain. For that convenience, we have to take the differences must be maintained d as a minus d, a plus d. Suppose if 4 terms are in AP, then they can be taken as a minus 3d, a minus d, a plus d and a plus 3d. Suppose how many terms are there? 3 terms are there. A minus d, a plus d. Suppose 4 terms are there, what you have to take? A minus 3d, a minus d, a plus d, a plus 3d. See their differences. This is 2d. The difference is 2d. Here to here is also 2d difference. Here to here is also 2d difference. Therefore, it forms also an AP, but their common difference is 2d. In the above, the common difference is d. Okay. Next one. 5 terms are in AP, then they can be taken as a minus 2d, a minus d, a plus d, a plus 2d is there. So what is the difference here to here? D. The difference from here to here is also d. Here to here is d. Here to here is also d. So suppose 5 numbers are there, you have to maintain in this manner. A minus 2d, a minus d, a plus d, a plus 2d like that. Now, when you are coming to the geometric progression, the next progression is geometric progression, a series in which each term is obtained by multiplying the preceding term by a fixed quantity is called geometric progression. This fixed quantity is called common ratio. This fixed quantity is called the common ratio. So, consider a series. The series have terms. These terms are said to be in geometric progression if they maintain the condition that the ratio of the term to its preceding term except the first term must and should be maintained the same constant. That constant is called the common ratio and the first term is a whatever it may be. That series is said to be in the geometric progression. Read once again. A series in which each term except the first term is obtained by multiplying the preceding term by a fixed quantity or divide the term by its preceding term. Both are same meaning. Gets a constant. We say that sequence is said to be in the geometric progression. Understand? Suppose nth term of geometric progression is a into r power n minus 1. The geometric progression is maintain this form ar square, ar cube, ar power 4 and so on. For this term, this is the preceding term. For this term, this is the preceding term. This term is obtained by multiplying r with the preceding term, we obtain ar square. This term ar cube is obtained by multiplying r with ar square, we obtain ar cube. Or divided this ar by a, we obtain r. Divided ar square by r, we obtain again r. divided by AR cube with AR square. Again you get R. AR power 4 by AR cube. Again you get R. So this sequence or its corresponding series terms are in geometric progression. The terms are in the geometric progression. If you consider any series or sequence, the terms maintains geometric progression if they maintain such a manner that if you multiplied every preceding term by a constant, you obtain the next term. Or dividing in the same order of the any two consecutive terms of the number terms of the sequence or corresponding series, we obtain the same constant. We say that is the terms forms a geometric series or progression. AR square, AR cube, AR power 4 and so on. This is of the form. What is AP form? For AP form is what? A plus B, A plus 2D and so on like that. Now geometric progression is in this manner. The nth term of the geometric progression is A into R power n minus 1. How it is happened? First term is what? A into R power 0. Second term AR power 1. Third term AR square and so on by writing the general term AR power n minus 1. This is A into R power n minus 1. What is A? First term. What is R? Common ratio. That is common ratio. N is the number of terms in the series. Okay. Now, this is the thing. A is in the first term, R is the common ratio of geometric progression. Then the series is of the form A plus R, AR plus AR square and so on. I already read that one. Nth term of geometric progression is AR power n minus 1. Next one. The sum of first n terms of geometric progression is A into 1 minus R power n by 1 minus R less than 1. If R less than 1, sum of geometric progression. So what is S here? A plus, AR plus, AR square plus, AR cube plus and so on up to plus AR power n minus 1. It's a sum. Is what I am saying. A into 1 minus R power n by 1 minus R. A plus, AR square plus, AR cube plus and so on. If you take common A, 1 plus, R square plus, R cube plus and so on up to R power n minus 1. This is S. You multiply R with that one. R into S we obtain. So A into R plus, R square plus, R cube plus and so on up to R power n we obtain. This is 1 times of S. Now subtract this equation from this equation, we obtain 1 minus R times of S is equal to A into R gets cancelled, R square gets cancelled, R cube and so on gets cancelled, R power n minus 1, R power n minus 1 again gets cancelled. So we obtain 1 minus R power n is there. 1 minus R power n is there. So 1 minus R times of S is equals to A into 1 minus R power n. Now S is nothing but A into 1 minus R power n by 1 minus R we obtain. So this is R less than 1. The sum is obtained by A into 1 minus R power n by 1 minus R. So if sum of the first n terms of the geometric progression is A into 1 minus R power n by 1 minus R. For R greater than 1, we obtain A into R power n minus 1 by R minus 1. Okay. Now, that is equals to A into R power n minus 1 by R minus 1 if R greater than 1. And that is equals to NA if R is equals to 1. N times of A for R is equals to 1. Again, for mod R less than 1, the sum of infinite geometric progression is A by 1 minus R. This is said to be S infinity. S infinity is obtained by A by 1 minus R. S infinity is A by 1 minus R. For mod R less than 1. Why? what is Sn value? Sn is equals to A into 1 minus r power n by 1 minus r for r less than 1, mod r less than 1. Understand? As n tends to infinity, what happened? This value is mod r less than 1, then it goes to 0. Therefore, S infinity becomes what now? A into 1 minus 0 by 1 minus r. That is nothing but A by 1 minus r, my dears. That is nothing but A by 1 minus r. So for mod r less than 1, S infinity is equals to A by 1 minus r. Every term of geometric progression is multiplied by a fixed real number, then the resulting series is also geometric progression. Understand? Every term of geometric progression is multiplied by a fixed real number, then the resulting series is also geometric progression. What are the terms of geometric progression? A, AR square, and so on. If you multiply it by some k, you obtain KA, KAR, k times of AR square, and so on. Now KAR by KA is what? R. KAR square by KR is what? Again R. So the ratio is same. By multiplying this term with R, we obtain this term. By multiplying R with this term, we obtain this term, and so on. So this resultant is also in the geometric progression. So the terms of the sequence or corresponding series are maintain the geometric progression, because they maintain the, by multiplying a fixed constant to the preceding number, we obtain the next number. In the same order, we obtain the geometric progression. So the resultant is a geometric progression. Next one, every term of geometric progression is raised by the same power, then the resulting series is also in the geometric progression. So if you consider any geometric progression, you have terms, each term is raised by the same power, the resulting sequence or corresponding series is also geometric progression. For example, consider the terms of a geometric progression, that is AR square, AR cube, and so on. These are the terms of series of geometric progression. Now, I am going to raise the powers by some k, A power k, AR power k, and AR square power k, AR cube power k, and so on. The terms are raised by the k for each term. Now see, each term is multiplied by A power k, preceding term multiplied by R power k. What happened? R power k into A power k is what? AR power k. And again multiplied by R power k, what happened? AR square power k. So this is also in the geometric progression. R check by divided this number by this number. A power k, R power k by A power k. This is R power k. Again, AR square whole to the power of k by AR power k. This is also R power k. So R power k is the common ratio for the geometric progression of new obtained from the AR square, AR cube, and so on. This is the new sequence. These are the terms of the sequence. These are in geometric progression. By applying the condition, it is valid. Its common ratio is what? R power k. Its common ratio is your R power k. Okay. So this is the way to define the geometric progression. In the next class, we will let us see what are the geometric means like that.